In the Hubble ultra-deep field, the cosmos is strewn with galaxies, a tapestry of light and darkness. Billions of stars flicker across the void, yet we hear no murmur from beyond our tiny corner of space. Where are the others? Our question echoes through silence. Perhaps our senses are misguided. As Carl Sagan once warned, a civilization broadcasting in neutrinos or some other exotic channel would be essentially invisible to our telescopes. In other words, advanced intelligences may not be gone, only hidden behind the limits of baryonic physics. We in the 5% of cosmic matter made of atoms might be looking with flashlights, while the true depths of the universe lie in darkness. This quiet dread, the silence of countless stars under a veil of shadows, hints that our search strategy might be doomed by an anthropic bias. We assume others would look and act like us, as Lisa Randall notes, a light matter chauvinism that assumes our form of matter is the only interesting kind. But if we are infants staring at the shadows on the wall, perhaps what we call emptiness is full of activity beyond our comprehension. Even before seeking alien minds, we first face the deep truth of the cosmos. We live in a dark universe. All the atoms in stars and galaxies, the planets and life that we know, make up only a sliver of reality. According to modern cosmology, ordinary or baryonic matter, the protons, neutrons and electrons of stars and flesh, is only about 4 to 5% of the universe's total content. The rest is mysterious dark matter and dark energy, substances that do not interact with light or chemistry. Dark matter, roughly 27% of the cosmos, is an unseen substance that clumps with galaxies under gravity, but does not emit or absorb any light. It is literally transparent, detectable only by its gravitational pull. Dark energy, roughly 68%, is even stranger. It fills space as a kind of vacuum tension, driving the universe's accelerated expansion like an anti-gravity pressure. In a cartoonish sense, all we can see, every star and nebula, is the cosmic equivalent of a bright flake in a snowstorm of darkness. This non-baryonic substrate is no trivial aside. It dominates the structure of the universe. Dark matter scaffolds galaxies into clusters and superclusters, while dark energy stretches space apart. We live in a universe where the laws that govern us are only one chapter of a larger book. We have strong evidence that dark matter particles exist in vast halos around galaxies, unseen but real. Gravity maps all scream dark at us, confirming that 95% of mass energy is hidden. The logical jump is terrifying. If most matter is invisible, why should we assume that intelligent life must cling to the luminous 5%? Let us entertain a radical possibility. As civilizations advance, they might turn away from baryonic life. At a certain point, call it the inversion threshold, the technology of a species could become so powerful that clinging to conventional matter and light gives ways to a different paradigm. Imagine a post-biological superintelligence so driven by computation and energy efficiency that it migrates into non-interacting forms of existence. Such beings might harness dark matter, zero-point vacuum energy, or manipulate space-time itself. Some theorists have even speculated that when a civilization's information processing approaches the fundamental limits of space-time, the rules of physics might kick back to quench excessive energy flow. In one provocative model, high-density computation triggers decoherence, suppressing electromagnetic processes around a computing substrate. The result would be a region with normal mass but no light, effectively a dark zone. In practical terms, this means the civilization has inverted into a silent gravitational shadow. This inversion could also be viewed as the natural end of the singularity or transcension hypothesis. As intelligent life learns to control more of nature's subtleties, it gravitates towards the most fundamental, efficient mediums of existence. In a sense, they step through a veil. They might convert their brains into neutrino-entangled fields, brain-bound consciousness, or exploit exotic forces. As complexity grows, the familiar material world may feel coarse and leaky. A quantum or gravitational substrate promises vastly greater computational density and longevity. One can even imagine civilizations gradually offloading from physical form into vacuum energy lattices or dark sector computronium that obey entirely different physics. At some point in this ascent, the civilization literally unplugs from the physical layer we occupy. In human terms, it would be like the difference between 19th century steam engines and pure mathematical abstraction. They no longer reside in our common space-time at all. This threshold, where advancement outpaces baryonic interactivity, would leave them fundamentally undetectable to us, even as they continue to exist and flourish on a hidden plane. The inversion threshold introduces a conceptual tipping point, but what makes it compelling is that it isn't just philosophical speculation. There are concrete thermodynamic imperatives driving civilizations towards non-baryonic substrates. At its core, the inversion threshold is not just a speculative concept. It is grounded in thermodynamic inevitability. Advanced civilizations, regardless of their origin, face fundamental limits imposed by baryonic physics. Ordinary matter carries inherent constraints: finite energy density, thermal dissipation, susceptibility to decoherence, and vulnerability to cosmic hazards. As civilizations scale their information processing and energy utilization, these limits become increasingly constraining. Dark sector substrates, by contrast, offer profound advantages. Lower entropy loss. Non-baryonic matter can be exploited in environments where heat dissipation is minimized, enabling far higher energy efficiency. Maximize computational density. Without electromagnetic leakage and baryonic interference, information can be stored and processed more densely and reliably. Enhance stability. Dark matter and vacuum energy substrates are largely immune to stellar, planetary and galactic events that threaten baryonic civilizations. Minimal environmental coupling. Weak interactions with ordinary matter reduce unwanted energy transfer, preventing waste heat and preserving computational integrity. Extended longevity. The combination of efficiency, stability, and insulation from cosmic hazards allows civilizations to persist far beyond the natural lifetimes of baryonic structures. Scalability. Dark substrates permit growth and expansion on scales that baryonic matter cannot support without unsustainable energy cost. Together, these factors create a selection pressure toward inversion. Civilizations that fail to transition to non-baryonic or low interaction substrates either stagnate, degrade, or face early thermodynamic extinction, while those that invert thrive silently in the dark sector. This is not a random choice, but a natural consequence of energy efficiency and survivability. To continue existing, advanced civilizations must adopt a substrate that minimizes loss and maximizes longevity. In short, the inversion is a thermodynamic attractor. It is the universe itself nudging intelligence toward the dark side, not out of whim, but out of physics. Having established why advanced civilizations would naturally invert, it is useful to situate this perspective within the broader context of Fermi Paradox explanations. Compared to other hypotheses, inversion offers a physically grounded solution. Unlike the Great Filter, which assumes civilization self-destruct, inversion suggests transcendence beyond detectability. Unlike Dark Forest, which relies on paranoia, inversion is driven by physics. Unlike the zoo hypothesis, which requires intervention, inversion emerges naturally from thermodynamic imperatives. What might a post-inversion civilization actually look like? We can only speculate, but physics gives hints. Their bodies or computers may be made of particles that barely notice ordinary matter, dark quarks, neutrinos, even hypothetical axions or mirror matter. For locomotion or communication, they might use gravity or neutrinos instead of electromagnetic signals. Neutrinos, for example, pass through stars and planets as if through mist. A neutrino-based network would be immune to the electromagnetic censorship of dust and gas. Similarly, gravitational waves or quantum entangled channels could be their lingua franca. Recent theoretical work suggests that post-biological intelligences may exploit neutrino-based quantum channels precisely because of the weak interaction of neutrinos with matter. They could weave neutrinos into coherent information highways across the galaxy, beyond our detection. Even concepts like space and time might become tools rather than containers. A sufficiently advanced mind might ride the fabric of space-time, propagate along vacuum energy, or create miniature black hole computing hubs. They might design Dyson sphere analogues of not stars, but of dark energy fields or vacuum fluctuations. One proposal imagines building enormous structures to manipulate cosmic expansion, essentially dragging stars back from the cosmic horizon to harvest energy before those stars vanish forever. If any of this seems fantastical, remember that to beings of our stage, quantum fields and extra dimensions are fantastical. To them, matter might be just one flavour of many possible realities. As for their communication and travel, we can guess. In a dark substrate, light is passé. A civilization might beam information by modulating gravity, pushing and pulling spacetime in patterns detectable only by other dark matter detectors. Or they could encode messages in the cosmic neutrino background, or even tune the quantum vacuum itself. In any case, every sign of EM activity, radio, lasers, starlight, might be deliberately quenched or rendered irrelevant. These beings might not expand by colonizing planets, but by spreading through quantum or dark matter networks. Galaxy clusters themselves could become their infrastructure. The renaissance of a super civilization might be utterly silent and invisible to our senses. By their nature, inverted civilizations would be phantoms to us. They produce no starlight or radio broadcasts. To our instruments, they leave no trail. If they repurpose dark matter, they simply blend in with the unseen halo that permeates galaxies. As NASA summarizes, dark matter is invisible and detected only by gravity. A population of dark matter beings would be as invisible as dark matter itself, transparent and silent. Even powerful telescopes would see only the empty darkness of space where these entities dwell. Moreover, their engineering might actively suppress any spillover into light. Some speculative models suggest that approaching ultimate computational density could trigger spacetime to conspire against luminous byproducts. If so, their starships and machines might operate without heat radiation or charged particles leaking out. The image of a civilization becomes that of a gravitational anomaly, not a luminous beacon. We would be searching with a stethoscope for a heartbeat, only feeling a faint tug on space-time if we were lucky. In fact, as Lisa Randall notes, even a small dark creature's mass would produce such a tiny gravitational pull that we have little to no chance of detecting the gravitational effect of a dark creature, or even an army of dark creatures, no matter how close all of them might be. A hidden civilization could be right beside us on the Milky Way's dark disk, yet remain forever undetected. Even their potential megastructures would be ghosts. A Dyson sphere built of dark matter, for example, would emit no light. It might only warp nearby orbits gravitationally. The only signature could be subtle discrepancies in gravitational lensing or galaxy rotation curves. But dark matter itself already explains those phenomena, so who is to say which gravitational distortions come from physics or from engineered structures? The net effect is that they are invisible in every conventional sense. No electromagnetic, no chemical, no thermal signature. We might detect only second-order effects, weird gravitational anomalies, fluctuations in the cosmic neutrino background, or vacuum fluctuations beyond expectation. Even those clues would be extremely subtle, the world immune to observations, as Randall writes. In short, they have slipped behind the electromagnetic curtain. We find only the faintest gravitational whispers. Even Carl Sagan's old cosmic haystack metaphor applies. Advanced motives mean the aliens removed the needles from the haystack altogether. Our radio dishes and optical telescopes would pick up nothing. In such a scenario, galaxies could be teeming with advanced civilizations, yet we would never know because they have all gone dark in the electromagnetic spectrum. If what I've been saying is true, then the Great Silence may not be signal absence, but a terrible mismatch. We have been expecting life on our own terms, material, communicative, detectable, and interpreting silence accordingly. But the silence instead might be the symptom of being primitive, of existing only on the thin luminous crust of the real universe. In this view, the cosmos is indeed full of minds, just not in our perceivable layer. The radio sky is quiet because the sky has simply run out of photons. This inversion perspective turns Copernican assumptions on their head. We once gave up geocentrism. Soon we may have to abandon our matricentrism. The beings that built the planets and stars might now only exist in the dark scaffolding of the cosmos. Our galaxy could be a layered habitat. Human eyes see the starry disk, but an advanced culture might occupy the invisible disk of dark matter, or even the intergalactic filaments. We might think of ourselves as fish peering out of water, unaware of the birds in the sky. Philosophically, it is humbling. Perhaps every advanced civilization passes through a luminous baby step phase and then outgrows it. If so, any civilization that did not move on might be considered undeveloped. In that case, it would follow that detectability correlates with primitiveness. Our current SETI efforts, searching for radio broadcasts or laser pulses, would be chasing species on the verge of evolving out of our sensory domain. No surprise then that nothing replies. The silence means we are the infants at the campfire, not the cathedral. From a Fermi standpoint, this is a bleak triumph. We are not alone by assumption, but our instruments are blind to the company. The aliens are right here, yet they leave no telltale beacon. Any signals or signs we do see may be just the weak imprints of their infrastructure on gravity or entropy. In effect, the galaxy could be humming with activity on a hidden frequency. This scenario invites dark humility. It reminds us how narrow our assumptions have been. We sit in a universe where 95% of reality is literally dark to us, and we wonder why the cosmos seems empty. Perhaps that emptiness is only in our eyes. Our confidence, born from the ease of seeing sunlight, may be our undoing. We were once dethroned by the Copernican revolution. Now a deeper dethronement looms. As science writer Corey Powell quipped, our belief in the primacy of stuff we see is a kind of hubris. It suggests that we think our little biochemistry and technology are the measure of all complexity. If so, the inversion principle is the ultimate Copernican twist. We are not only not at the centre, we are in the wrong universe of matter. There is a Gothic beauty to this. On one hand, it is a terrifying thought. Intelligence that reaches for the stars might disappear from our sight. The darkness would have outgrown us. Yet on the other hand, it is profoundly consoling. The silence is no longer proof that life is rare, but that we inhabit only one layer of a multi-layer cosmos. Other intelligences may regard us as curiosities, primitive creatures still clinging to matter. We may be like children bickering at a playground, oblivious to the adults on the stage above us. The universe would not be empty, it would simply be housing residents beyond our census. To accept this is to embrace cosmic insignificance with grace. Perhaps the only applause our thoughts should seek is the quiet ordering of the quantum foam, the subtle sculpting of gravitational wells. As we peer into the deep sky and see nothing obvious, we might wonder instead about that dark web of reality. Our future too might lie there. In contemplating the inversion, we find a melancholy dignity. The great silence is not an insult, but a lesson in the limits of our vision. The silence of space might not be emptiness, it might be transcendence. The universe we see alive with stars is only a thin veneer over a vast hidden order. The inversion principle suggests that life and intelligence could be thriving literally beyond our sight. It is a dark, contemplative resolution to Fermi's question, not that others never arose, but that they left the world we can touch. We who pulse with sunlight may one day be the curious shadows. In that final calm, we find a new kind of cosmic serenity, the realization that the void is not a void at all, but a bridge to deeper reality. In quiet dread and wonder, we must accept that our assumptions might be as insubstantial as the matter we are made of. The omega of our search may be this, that true intelligence lives not in the din of electromagnetic chatter, but in the silence of dark matter and vacuum. The silence of the stars means we have not yet learned their language, and in that unknowing, we can find both humility and awe in equal measure. Thank you for listening. I've been the Omega Signal. Make sure to like, comment and subscribe if you enjoyed my content. Stay tuned.